Okay, so in this video we're going to have a look at injective, surjective and bijective functions, and we'll focus on questions that involve restricting the range, the domain, or possibly the codomain. Okay, so if we have a look here at 16, part 1, and I've written above here the tests that we carry out for all three, and then the conditions that they must satisfy to either pass or fail the tests. So 16 part 1, we're asked if the function is injective. So for injectivity, we're going to carry out our horizontal line test. So we run our line across. We see here it intersects twice. So what's going to happen is it will fail. So we say it's not injective as it fails the horizontal line test. Crosses more than once. Okay, and in part 2 now we're asked under what circumstances would the function be surjective. So for surjectivity, it's going to pass the horizontal line test, that's fine, it crosses at least once, and then it fails on our second condition, so the range must equal the codomain. So our range for this one on our y-axis, we see our maximum here is 2, and then it goes down to minus infinity. So our range on the y-axis goes from 2 all the way down to the minus infinity, but our potential outputs, so our codomain is or. So we need to restrict our codomain in order to make it a surjective function. So our codomain should be minus infinity 2, and we use a rounded bracket on minus infinity because we don't know the actual value for it, so we can't say or confirm that it ever actually touches that value. But on the other hand, we know for definite our function touches 2, so we use a square bracket for that. So it should be minus infinity 2 to match the range. And we just need to write that now for our mapping notation. So it'll be f maps or to minus infinity 2. And that's 16 answered. Okay, so we'll come and have a look at question 14 now below it. And we're being asked in a little bit more detail here. So part 1 asked, is it surjective? We're going to run our horizontal line test. That's okay. And then we're going to check if our codomain equals the range. So we were told our codomain is the set of positive reals, so 0 to infinity. And we check our range. We see here the lowest value they tell us is 0. And it heads all the way up. And our function keeps going on both sides to plus infinity. So we're getting the same values for range and codomain, so we pass there. So we can say f is surjective. And our reason, it passes the horizontal line test. And the range is equal to the codomain. That's part 1. In part 2 we're asked, is it surjective? So is it injective? We've run our test for surjectivity and it's intersected twice. So we can say f is not surjective. And our reason is that it fails the horizontal line test. It crosses more than once. Okay. In part 3, we've been asked to suggest a restricted domain and range to make f bijective. So essentially what we're going to do here is if we take our function, we need to make it injective and split it in half. If I just took the left hand side, we'll call it option 1. We would have an injective function there, And likewise, if I just took option 2, I'd also have an injective function. Anywhere I draw my horizontal line, it'll only intersect twice. So what we're going to write there is that we need to restrict our inputs, so our domain, to -infinity, 0, because we know our x-axis here keeps going to -infinity, stops at 0, and goes from 0 then to +infinity. And then our range will be 0 and +infinity, or we can call that the set of or plus. That was option 1, and option 2 then we could restrict our domain to 0 +infinity, and our range will again give us positive outputs. So what will happen there is it'll ensure our codomain and our range are equal. It's going to pass our test for injectivity. It'll only intersect once, and therefore F would be bijective. Okay, that's 14 done, and now we come down to 15. In part 1, we're asked to write down the range of the function. So if we have a look here, we're dealing with, they've told us y is equal to e to the power of x, so we have an exponential function. So the x-axis is what we call the asymptote. It never actually touches it. So it'll work all the way up, and it's going to keep going and get closer and closer and closer to infinity, but again, never actually touch it. So the range will be 0, rounded bracket, because it doesn't touch it, as we said, to +infinity. That's part 1 answered. Part 2 asks if it's injective. We'll run the horizontal line test. We can run it a couple of times. We see it's going to be injective. As it passes the horizontal line test. In part 3, we're asked if our function is going to be surjective in the range y is greater than 0. So for that condition, for surjectivity, our horizontal line test is going to have to pass at least once, and then our range is going to have to equal our codomain. So we see from our answer in part 1 that our range was 0, infinity. Because we know it's an exponential function, our set of possible outputs can only ever be positive values. So we've satisfied that. We've satisfied the horizontal line test. We'll say as it passes the horizontal line test, crosses at least once. And our range equals our codomain. And the last part, it's just a little bit cut off. But we're being asked to explain why the function is bijective for x an element of R and y is greater than 0. So we've essentially answered this already between parts 1, 2 and 3. So we're just going to reiterate that. So y equals e to the power of x is bijective for x is an element of R as it's both injective and surjective. under those values. Okay, and there's those questions done.